Welcome class in our seventh lecture. Today we will study about the uh, advantage of parallel combination over series. Okay, so it's our seventh lecture. So here we start with the in parallel. First हमें क्या समझना है कि which type of combination is better, parallel combination or series. Okay, so first thing हमें ये समझना है कि कौन सा better है. So हम अपने घर में जो combination use करते हैं वो है parallel combination. Okay, it's not series combination, it is parallel combination, because you know that each appliance must get the same voltage. There should be no issue related to voltage. So voltage हर appliance को एक सा मिले, इसलिए हम अपने appliances को connect करते हैं in a parallel combination. Is it clear to you? So what are the advantage of parallel over series? So first advantage is that in parallel combination each appliance gets the same voltage. As I told you कि हमारे घर में जितने भी appliance हैं, टीवी है या बल्ब है या रॉड है, each and every appliance gets the same voltage as the source is supplying. Is it clear? Now you can see I have drawn a circuit here. Bulb, fan and a TV all are connected in a parallel combination, and these all getting same voltage of source, that is 220 voltage. Okay, second is in parallel combination overall resistance remains lesser than in series. Okay, जो ओवरऑल रेजिस्टेंस है पैरेलल कॉम्बिनेशन में वो हमेशा सीरीज के कंपैरिजन में लेसर रहता है. ओके, लेट्स सी एन एग्जांपल. लेट्स टेक एन एग्जांपल. हमारे पास सपोज 1 लाख ओम एंड 1 ओम के दो रेजिस्टेंस हैं. ओके, अगर हम इसको सीरीज में कनेक्ट करते हैं सो द नेट रेजिस्टेंस विल बी 1 लाख 1 ओम. Okay, 1 lakh 1 ohm. But what happens when we connect it in series combination? Okay, look here. What happens here? 1 lakh and 1 ohm connected in parallel combination. So the net will be the LCM will be 1 lakh. Here it comes 1 plus 1 lakh. So it comes 1 lakh 1 upon 1 lakh. So when you reciprocal it, so it comes R is equal to 1 lakh 1 upon, 1 lakh upon 1 lakh 1, which is nearly 0.99 ohm, or you may write it as 1 ohm nearly. Okay, so you can see the comparison when these two are connected in series. So the net resistance was 1 lakh 1 ohm and now the value is nearly 1 ohm. Okay, so it is just 1 lakh times in series combination, okay, as compared to the parallel one. Parallel में net resistance आ रहा है less than 1 और series में आ रहा है 1 lakh 1. So you can see that so the overall resistance in parallel combination is always lesser than in series. Okay, so the third point is that in parallel combination we can give separate switches to each appliance. Like in your domestic appliance, domestic circuit, bulb is getting bulb having a separate switch, electric fan having separate switch, your TV having separate switch. So each appliance having separate switches. They all are not operated by same switch. Okay, so whenever you need to switch off any appliance, you just switch off it, and other devices, other appliances doesn't affect by it. Okay, so like we have a bulb, fan and TV, and suppose मैं रात को सोने जा रहा हूं. कहां जा रहा हूं? सोने जा रहा हूं. सोने के टाइम पे मैंने टीवी को कर दिया ऑफ. Okay, switch is off now. बल्ब को कर दिया मैंने ऑफ, right? But my fan is still working. So you can see that a amount of current is coming out from the source, and that amount of current will pass through fan and will reach to the source again. So this means that this amount of current will not pass through this bulb, will not pass through TV because the circuit is broken here. Circuit is open here. Okay, so current will not pass through bulb and current will not pass through that TV. Okay, so you can use any appliance according to your desire, according to your requirement. Okay, is it clear to you? So now the what happens in series? In series we cannot give separate switches. Okay, why? Because the amount of current coming from the source, suppose यहाँ पे आपने इस फैन को बंद कर दिया, so फैन जो है उस करंट को आगे जाने नहीं देगा, right? यहाँ पे स्विच ऑफ हो गया है, स्विच ऑफ हो गया है, so सर्किट ब्रोकन हो गया है, सर्किट ब्रेक हो गया है. सर्किट ब्रेक होने पर करंट आगे नहीं जा सकता, means you can not use that TV at the same time. Okay, either you have to use both the appliance with low voltage, or you can use, or you can't use any appliance. Okay, so you cannot give separate switches in series arrangement. Is it clear to you? So now the fourth point, in parallel combination, if one appliance is stop working, others do not. पैरेलल कॉम्बिनेशन में अगर आपके घर में सपोज एक टीवी खराब हो गया, सो क्या ऐसा होता है टीवी खराब होने से सारे अप्लायंसेस बंद हो जाते हैं? आंसर इज नो. मींस यहां पर जितने भी अप्लायंसेस हैं, क्योंकि वो पैरेलल में कनेक्टेड हैं, सो सीरीज वाले वायर के थ्रू करंट पास नहीं होगा, लेकिन बाकी सारे अप्लायंसेस में करंट पास होता रहेगा. यू कैन सी हियर, सपोज योर टीवी स्टॉप वर्किंग, टीवी ने काम करना बंद कर दिया, वो फ्यूज हो गया, उसका बोल गया हो. सो व्हाट हैपेंस इन दैट केस, फैन और बल्ब दोनों में करंट पास होता रहेगा, दोनों काम करते रहेंगे, बल्ब भी काम करता रहेगा, फैन भी काम करता रहेगा, लेकिन टीवी आपका काम नहीं कर रहा है. बट व्हाट हैपेंस इन सीरीज, सीरीज में एक भी अप्लायंस अगर खराब हुआ, सो वो करंट को आगे जाने नहीं देगा, एंड अदर अप्लायंस कैन नॉट बी यूज्ड एट दैट टाइम. इज इट क्लियर टू यू? सो दीज ऑल फोर आर एडवांटेजेस ऑफ पैरेलल कॉम्बिनेशन over series. That's why our domestic circuit is based on parallel combination, not on series. So just look here. Our next topic is electric energy. Electric energy is that energy supplied by the source in maintaining the flow of current. Suppose आपको जब आप इलेक्ट्रिक सेल से कुछ चीज करंट फ्लो करा रहे हैं किसी सर्किट में, सो इलेक्ट्रॉन्स के मूवमेंट के लिए उस सेल को कुछ काम करना पड़ेगा, उस इलेक्ट्रॉन फ्लो में सेल को कुछ काम करना पड़ेगा, और काम करने के लिए उससे कुछ एनर्जी चाहिए होगी, राइट? सो दैट एनर्जी विच इज रिक्वायर्ड टू पास टू फ्लो द करंट इन द सर्किट is called electric energy. Is it clear to you? So energy supplied by the source in maintaining the flow of current is called electric energy. So we can use, we can take out a formula for that. You know that electric potential formula, V is equal to W upon Q, where W is the work done and Q is the charge, right? So you can write this formula as W is equal to VQ, and we know that I is equal to Q upon T. First formula. The rate of flow of charge is known as current. So Q could be written as Q is equal to IT. Okay. So at the place of Q, I'll write here IT, and at the place of W, I can write E. Okay. Means work done is equal to energy consumed. Okay. So this is your electric energy formula. E is equal to VIT. E is equal to VIT. Okay. So the next thing is that, okay, now we'll go to the next topic, and that next topic is based on, it is very important topic actually. So heating effect of electric current. Okay. Heating effect of electric current is that heating effect create करता है current. Can you see that? You can observe it in your daily life that you use many appliances which which you are using for the heating purposes. Okay, heating purpose. Okay, like your electric heater, your electric iron, your electric kettle, your electric water heater, your electric rod, okay, your electric toaster. Okay, so there are many appliances which you use for heating purpose. Okay, which always runs on electric current. Okay, so this is one of the effect of electric current. There is another effect of electric current, that is magnetic effect, that we will discuss in the next chapter. Okay, magnetic effect of electric current. Okay, that is only based on magnetic effect, but here we will discuss about the heating effect of electric current. So heating effect is actually based on Joule's law of heating. Just remember it, Joule's law of heating. So the heat produced, what it says, heat produced in a resistor, in a resistance, is directly proportional to the, you know that कि अगर resistance क्या करता है, करंट के पाथ में रुकावट क्रिएट करता है, हिंड्रेंस क्रिएट करता है. ओके, जब करंट के पाथ में रुकावट होगी, सो क्या होने वाला है, इलेक्ट्रॉन्स तो फ्लो हो रहे हैं, इलेक्ट्रॉन्स में हुई धक्का मुक्की, और जब धक्का मुक्की होगी तो गर्मा गर्मी क्रिएट होगी. गर्मा गर्मी में क्या होगा, सो द इट क्रिएट्स अ लॉट ऑफ हीट. ओके, सो जब भी जैसे कि फ्रिक्शन क्रिएट्स हीट, friction is a hindrance in the motion, so in the same way resistance is the hindrance in the flow of current. Okay, तो यहां पर resistance की वजह से heat create होती है. so ये जो heat है ये किन चीजों पर डिपेंड करती है. so the first thing is it depends on, it is directly proportional to square of current flowing in it. X is directly proportional to square of I. ओके, स्क्वायर ऑफ करंट. मगर अगर आपको अगर आपको हीटिंग इफेक्ट बढ़ाना है, सो आपको करंट अमाउंट को बढ़ाना पड़ेगा, जो उस रेजिस्टेंस के थ्रू पास हो रहा है, उस करंट अमाउंट को आपको इंक्रीज करना पड़ेगा. राइट. सेकेंड इज द रेजिस्टेंस, वैल्यू ऑफ रेजिस्टेंस. रेजिस्टेंस को अगर आप बढ़ा देंगे, ओके, लाइक अगर आप 100 ओम की जगह 1000 का लेंगे, उसमें ज्यादा हीटिंग होगी. 1000 की जगह 10,000 का लेंगे, उसमें और ज्यादा हीटिंग क्रिएट होगी. एंड इफ यू विल टेक अ 10 lakh ohm resistance, so the heating will be more and more. Okay, so H is directly proportional to the R. Heat produced is directly proportional to the value of resistance. Third thing is the time of current, the time of current flow. So जितनी देर भी आपका करंट फ्लो होगा, जितनी ज्यादा देर करंट फ्लो होगा, उतना ज्यादा हीट क्रिएट करेगा. फॉर एग्जाम्पल, जैसे ही आप अपने इलेक्ट्रिक आयरन ऑन करते हैं, क्या हीट प्रोड्यूस जो उसमें होती है 10 मिनट बाद भी क्या उतनी ही हीट प्रोड्यूस होती है? नो, 10 मिनट बाद वो ज्यादा हीटेड होती है, बिकॉज द टाइम ऑफ करंट फ्लो is increasing the heating effect. Okay, so H is directly proportional to the T. So combinedly we can write these all three statements in just one line. H is directly proportional to I square RT. When you remove the proportionality sign, a constant comes at that place, K, and the value of K is 1. So K की जगह 1 रखने पर it becomes H is equal to I square RT. So H is equal to I square RT is the formula of Joule's law of heating. Okay, just remember that. We will do some numericals based on that. Okay, I'll give you some numerical in the next lecture. Hope you like the lecture. Okay, thank you.